So we calculated posterior probabilities for the airport being at location A and at location B, given prediction by the company that the airport will be at location A, or given that the airport is predicted to be at location B. And we have also these probabilities. What's the likelihood the company will actually give us prediction of A or prediction of B? This will also be useful. Now we're ready to build a decision tree that will incorporate all the events and all decisions that we have here in this adjusted problem. So the first thing I want you to realize is that what's the sequence of events, right? The order or sequence, order of decisions and events. So you see, in the previous tree that we had just one decision, purchase the land, which land purchase options do we choose, and then that was followed by airport location, right? Now in this case, we have also information. And of course, information, if anything, if we use information, we should definitely try and obtain it before the land purchase decision. So the first thing should be obtain information or not. Obtain information or not. If you obtain information, then we have to check the prediction, right? Check the information that we get, right? I mean, we buy information to find out what it says, and then we will decide, right, on decide land which land purchase. Alternative to choose. And then the last thing would be chance node, right? Find out which airport location is actually chosen, right? Which is out of our control. Right? So the order of events is this. And we have to be careful when we build the tree that we first consider the decision. This is our first decision. Decide to obtain the information or not, right? And then check the information and then decide after we check the information, if you did obtain it, of course, whether to purchase land or not. So I'm going to build a decision tree in the same sheet where I have this analysis of information, because I also want to be able to link to those probabilities from my decision tree. So I'm going to go here somewhere at this point, let's say, and I'm going to open precision tree. I have to open the add-in. And now I create a new decision tree. I could actually modify my existing small tree that I created before, but I think it's easy. It's better I keep this tree and I create a new one where I will perhaps use or copy the old one at some point. So my decision tree here will be, right, another tree called Magnolia, but perhaps I'll call it with info, right? Magnolia with information. And then the first node, as we said, right, the first is decide to obtain the information or not. So I have to change this to a decision node, right? And this will be info decision, right? Information decision. That's information decision, right? And let's call it, the first branch, I'm going to call it no info. And the second branch, I'm going to call obtain info, right? I'm on purpose choosing the negative option first because I want the top part to look similar to my previous tree. So if I don't obtain information, there is no profit or costs, right? The payoff is zero. However, if I obtain information, if you recall, the cost of information is $800,000 or $0.8 million. So I have to record this here as negative 0.8, right? This will be the payoff. Now, the first branch, when I don't obtain information, this part, this node, will be exactly the same. There will be exactly same subtree that I have created before. So let me try to go to my old tree, right-click on the root node of this tree, right, the first decision node, and try to copy this subtree from here, go here, and then right-click on this and paste this subtree here. It will, of course, delete a lot of things, but as you will see, and let me actually zoom out a little bit, right? This is exactly the same tree that we had before, right? Let me actually hide this to have more space. So we have now a tree which is, if I don't get information, I still have the option of doing what I did before, which means I decide which land to purchase, and then the airport is at A with 40% or at location B with 60%, and my optimal decision still holds as before, right? Choose location B for a maximum of 3.4 expected payoff, $3.4 million. Now, what I need to now add is what happens when I obtain information. So again, you see, we have to go back to our plan. So the top part, we actually decide not to obtain the information, and therefore point number 2 is irrelevant. If we don't obtain information, we can't check it. We go immediately to third and fourth point, which were decide to purchase land and find out if the airport is here, right? These are the nodes. But if we obtain the information, we then have to check the information. Now, what kind of node will this be? Now, if we check the information, this is something that is out of our control. It will happen, and the prediction will be A or prediction will be B. It's not a decision node, it's a chance node. The company that we are hiring will study some information and find out is it in location A or location B. So here, this node, I have to change it to a chance node, and this chance node will have two options, right? The one option will be the information, right? So let's call it actually this prediction information result, right? Will be predicts A or predicts B, right? Now, I'm going to leave probabilities 50% and value 0. Values are 0 because just that the fact that it predicts something doesn't have any monetary impact, negative or positive, but the probabilities are not 50%. However, I'm going to leave them now 50% because I want to search for those probabilities. So what are those probabilities? What's the likelihood that the information will predict A, or what's the likelihood the information will predict B? And what I want you to see is in the tables that we had earlier, we actually did calculate probability that information will predict A. It's this number, 46%, and this is probability it will predict B. It's 54%, right? And it's not the same as our prior probabilities for location A or B. These are the probabilities for predicting A, predicting B with this imperfect information. So this 46%, I will actually use references. Oops. I click here on the 50%, right? And this is a number I can edit, but I'm going to say equals, and I'm going to scroll up and select probability predicts this 46%, and here I will select equals. And notice, by the way, now it gives me an error value throughout the tree, because these two probabilities, 46 and 50, do not add up to 100%. They should, right? So if you have an error, maybe the probabilities don't add up to 100%. I need to make this equal to, and of course, this should be 54% complementary, right? Now there's no errors, and you see the probabilities are correct. So I have the first information decision, obtain information. Again, I should call it obtain, not obtain. Okay, and then the information predicts A or predicts B. Now, what happens when the information predicts A? We now have the third point, decide which land purchase alternative to choose, right? And then find out where the airport is. I want you to see that at this node, when the prediction is A, it's not obvious that we should choose A. Maybe we should still choose B, or maybe we should buy both A and B. We don't know, right? And the same here. Just that it predicts B, we shouldn't assume buying location B will be the right option, right? Let the tree decide. So in order for the tree to decide for us, we still have to consider at this and at this point in both of those outcomes, we still have to decide, allow the tree to choose A, B, A and B both, or none. So what I'm going to do is, again, copy this part of the tree, copy, and paste it here, right? Because it will be the same kind of tree. The tree is already, you see, becoming very big, right? When it predicts A, I have land purchase decision with all these possible outcomes. And when it predicts B, I will also have, paste, I will also have the same situation, right? Land purchase decision. However, what's different now, right? Payoffs are actually all the same. Payoffs will be the same. If I buy location A, I still have to pay 18 million. If it is location A, I still gain 31 million. What's different is the probabilities. So the probabilities here, 40% and 60%, are no longer correct. We have now posterior probabilities, right? So you see how this analysis of information and calculation of posterior probabilities affects our decision. Now it's this probability that is the probability of location A, given that if you go back, the information predicted A. It's no longer 40%. So I will say again here equals. I will scroll up and select this new probability of A, given that information predicted A. And here I will select equals, and I will select this probability that the location is B, given that prediction was A, right? And you see that changes the calculation, right? Because now there are different probabilities, so the expected value here will be calculated differently. And because this is the same, these should be the same probabilities, just for a different decision option here, decision alternative. So I'm going to just again say equals and select this probability, and here equals and select this probability. And finally, this one equals, again, say this equals this, right? So now, these calculations, you'll see, for example, that true is the decision. If you reach this node, what's the optimal decision? Is true, false, false, false. That means that when we reach the information predicts A, the optimal decision is to actually buy land at location A, which is something that we could have expected, but now this is confirmed through this calculation with adjusted probabilities. Now we still have to adjust probabilities when the information predicts B, and I'm going to do this exactly the same as before. Just remember that this predicts probability that the location A is going to be chosen given that it predicts B equals, and I have to choose the value from the second table. When it predicts B, what's the probability that will be A is this 22.22%. And the same here equals, what's the probability it will be B, given that prediction was B is 70, almost 78%, right? And same thing here. I will just copy because these are the same probabilities, equals 77.77, and then this equals 22, and this equals 77, right? And this is basically a complete tree. Now we are ready to look at the result and trace and find out what the optimal plan is, decoded from this decision tree. So how do we find out the optimal plan? Well, the tree, remember, is already rolled back. It is solved. All these expected value calculations are done in a backward way, starting from right back to the root node. So we have to go now back to the root node and see information decision. What is the decision that was taken, right? There should be a true value here. There is a false value here under no info and a true value here under obtain information. So that means the first information, the first decision about information, the tree decided to obtain information, right? We can start writing a summary somewhere here, let's say. So our plan is first obtain information, right? Obtain information is the decision. There is true here, right? And then we can also see now this is a chance node, so we might, after we arrive here, the company may predict A or it may predict B. So we have to check both of those branches. If it predicts A, right, what do we do? Well, the true is here. So if it predicts A, we buy land at location A. So our plan is to, if predicts A, buy A. That's the plan, if predicts A. If predicts B, let's see where the true is. Or if predicts B, it is buy at location B. Remember, it's not, shouldn't be that certain. Maybe it would be buy at both locations or something else, right? But it seems that 3 chooses correctly. 3, if predicts B, buy location B. So I want you to see that the plan is not a simple single stage plan, right? It's not just do something and see what happens. Now it's do something, then check the value, and if this value is A, then buy a location A, and then if this value is B, buy a location B, and then again afterwards, of course, we want to see where the airport will actually be and what our final value is. Now, expected value from this plan is 4.34. So expected value, the maximum, right? The maximum expected value from this plan is $4.34 million. Now I want you to see that this expected value, 4.34, is after accounting for the cost of the information, which was 0.8 million. So it appears that information was worth it, right? Because the value that we have now when we choose to obtain the information is higher than what it was before after accounting for information. So actually, after paying for the information, we still gain almost $1 million. Recall that before it was 3.4 million, now it's 4.34. So it's almost $1 million more after we already paid $800,000 for the information. And one last thing is, we can now look at these probabilities at the end. So here we will never reach these nodes, right? 0% and here 0%. Why? Because we don't choose this branch. We do not choose the branch not to obtain information. We chose this branch, and then we can see which actual places we can be in. I will just maybe highlight them rather than right? We can rather than build this risk profile just to save time. So there's 28% chance we'll be here and 18% chance we will be here, right? And now these are different payoffs because remember, in addition to this this positive payoff and this cost, we also had a cost of information, which is added here to this, so subtracted. So instead of 13 million that we had before, now we have 12.2 million, and here there is a bigger loss also. And this is 0%, 0%, 0%, right? 0%, but we also have these options. So we might arrive here with 12%, we will have a loss of 8.8 million. 42%, we will have a gain of 10.2 million. So you see, right, the risk profile, if you wanted to create it, would have 4 different possible outcomes with these values and these probabilities, and I hope they add up to 100%, right? 42%, another 12%, that's 54, and here 60, 72, and plus 28%, 100%. So our risk profile can be created by listing all those 4 options, right? And those options would be described as, in all cases, obtain information. And if it predicts A, choose A, and then the airport will be at location A. That's 28% chance in total. And then the value is 12.2, and then the other can be listed the same way. Now, why is this 28% probability here? You can actually verify that this is the correct probability by multiplying this probability that the airport is at location A by probability predicts A, 46%. This times this, all the probabilities that happened on the way should be 28% if you multiply them. Right? So we received a solution now. To summarize, we have a solution now for the Magnolia Inn's hotel chain problem, which included not just a decision of where to buy, which location to buy land in, but also a decision about information. We evaluated the value of perfect information, and we found out perfect information is actually the value of it was $8.4 million, much more than the value of this imperfect information, which was just $0.8 million. So we said it's worth considering this imperfect information. Then we calculated posterior probabilities, right, using the Bayes theorem, Bayes rule. We calculated posterior probabilities for this information. If the information predicts the location will be A, these are the probabilities for location A and B. If the information predicts B, these are the probabilities for locations A and B. And then we also calculated probabilities of prediction of A and prediction of B. And then we built a decision tree which has all the, it's actually 2-stage decision tree, which has first stage choosing to get the information or not. And if we get the information, we have a chance node to see if it predicts A or predicts B. And then the following land purchase decision and airport location chance node. And you see we have now an optimal plan that actually is much better, right, in terms of the expected value than the original one without additional information.